So let's continue on to what they call the general power rule. The general power rule is what I've been doing. The general power rule is the blue version that I've been doing. So we did have the official U substitution chain rule version, which was a composition of functions, rewrite it in terms of U and then multiply it. But here's what the general power rule says. This is really, again, what I've been using the entire time. The general power rule, if you look, it says what's the derivative of some function raised to the n power. You drop the power, keep the function the same to the power minus 1, and then you have to multiply times the derivative of the inside. I'm going to write that note here again. Don't forget to multiply by the derivative of the inside. So let me write that out here. Don't forget to multiply times the derivative of the inside. Very, 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 very important that you don't forget to multiply times the derivative of the inside. So again, I'm just going to start using the general power rule notation here. Again, the general power rule is, it truly is the chain rule. There's no difference here. Okay, so if we wanted to find y prime, we drop the power, 4, keep the inside exactly the same, x squared plus 3x to the power minus 1. Well, 4 minus 1 would be 3. But then we have to remember to multiply times the derivative of this inside. So I use the prime notation. You could all easily use the du dx, but this really, to me, helps me align it to, look, I dropped the power, kept the inside the same to the power minus 1. That's what I did right there. And then I just have that u prime right there. X squared plus 3x, let's take the derivative of that. The derivative of x squared is 2x. The derivative of 3x is 3 times 1, or just 3. So what do I really have here? Well, I can't do too much, but I can certainly multiply this. I don't have to, but I can multiply this 4 times the 2x plus 3, I guess. I mean, I could write the answer as 4 times 2x plus 3 times x squared plus 3x quantity cubed. That's the factored form of it. I'm perfectly fine with that. I could have distributed the 4, but notice I can't distribute the 4. You got to be really careful. You cannot distribute the 4 to the cubed one. You can only distribute the 4 to the linear one. So maybe you would have written 8x plus 12 times that quantity. Make sure you have parentheses, times x squared plus 3x raised to the 3rd power. No need, doesn't matter. I don't care really what you did there, if you distributed it or not. Other things that I see you could have done, there's an x in both of these, the x squared plus 3x. Technically, you could have factored out an x. Why would you? Any of these answers are perfectly fine. Don't overthink it. Great example, example 6, good test problem here. You know it's going to be on the test, finding the equation of the tangent line. Remember, we know there's multiple steps to finding the equation. The first one is find the point. Well, it gives us an x value. So sorry, the function is y equals the cube root of the quantity x plus 4, quantity squared, right? At x equals 4. So how do you find the point? Well, you look at x equals 4 and you plug it in. So this should be y into the original function, y equals the cube root. Don't know what the heck I'm writing. The cube root of 4 plus 4 quantity squared. So 4 plus 4 is 8, squared is 64. The cube root of 64 is 4. 4, 16, 64, yep. So that tells me that my point is the point 4, 4. Let's see if that's what you guys got. Please verify. But that gives me my point. The second thing that I need is the slope, right? And to find the slope, that means you need to find the derivative at that point. To find the slope at that point, you need to find the derivative of that point. So we need to find y prime. Well, let's go back and look at what y is. Y is the cube root of x plus 4 quantity squared. Well, I'm going to write that in exponential form because it's in radical form. That's x plus 4 raised to the 2/3 power. Remember, the exponent stays in the exponent and the radical is the denominator. So what does that tell us? Well, using the general power rule, that would tell us that the derivative of y is drop the power, So that'd be 2/3. Inside stays the same. X plus 4 raised to the power minus 1. Again, I cannot emphasize enough when it's fractions. I highly, highly, highly recommend that you use a calculator. 2/3 minus 1 is negative 1/3. But then remember, we always need to multiply times the derivative of the inside. Well, that's not bad because the derivative of x plus 4, derivative of x is just 1, derivative of 4 is 0, so the derivative of the inside is just 1. That's going to give us our derivative pretty quickly here. So this is going to be, well, let's think about it. The negative power of 1/3, we have to bring it to the bottom. A power of 1/3 means it's a cube root. So it looks like on top we have the 2, on bottom we would have a 3, and then we would have the cube root of x plus 4. So that's our derivative function, right? But now we need to look at that at x equals 4. So what do? Plug it in. Y prime would be equal to 2 over 3 times the cube root of 4 plus 4. Well, 4 plus 4 is 8. The cube root of 8 is 2. 2 times 3 is 6. So really what I'm looking at here is 2/6, which simplifies to 1/3. Again, I would encourage you, if you're not comfortable with your mathematics in your head like I am, with your arithmetic, use your dang calculator. You could have put all of this into your calculator. But why is this important? Now I have a point. I'm going to highlight that. I'm going to highlight that. My point is the point 44. I have a slope. My slope is 1/3. Now I can go to step 3 of finding the equation of a tangent line, which is using y minus y1 equals m times x minus x1, the point slope form, and then you solve for y. So in our case, we'd have y minus the y value, which was 4, equals m, we got 1/3, times x minus the x value again, which was 4. We're going to distribute that 1/3 to both of those terms. So I end up with y minus 4 equals, well, 1/3 times x is 1/3 x. 1/3 times negative 4 is negative 4/3. Still solving for y, so I need to add 4 to both sides. Again, please use your calculator when it comes to fractions. I'd have y equals 1/3 x and then minus 4/3 plus 4. Well, that's 12/3, so it looks like I'm getting a positive 8/3. My final answer for the equation of the tangent line would be y equals 1/3 x plus 8/3. Again, I strongly encourage you to check your answer, to remember what you're doing. You should be able to go on to Desmos here. In Desmos, you should be able to graph the cube root of x plus 4 squared. You should also be able to graph the equation of the tangent line, which was 1/3 x plus 8/3. What you should see is the line intersects the graph at that point for 4, and you should see the slope of the tangent line that we just got, the 1/3 x plus 8/3, the slope of that line should look like the slope of the graph of the cube root of x plus 4 squared. So the slope of the tangent line should be the slope of the graph, and they should at that point, which is the point 44. So always be sure to try to take that extra minute and verify your answer graphically. Again, I use Desmos to do my graphical verification.